good.
Next, we must go to the next speaker now, who is Ulf Andersson from the Swedish Space Society. He will be talking about more resources in the circular economy on the moon and on Earth. He is Vice President of the national NGO, Swedish Space Society, working to promote the space sector and space settlement. And he's also CEO of the consultancy Swedish Future Scanning. Please, Ulf, the floor is yours.
Hate to interrupt real quick.
Thank you, Niklas. But before starting my presentation, you might have to do something about the recording. Did you observe that the system said that the recording will stop in 2 minutes?
No.
Like 2 minutes ago.
It is still recording here.
Yes, it is, but it might
Nicholas,
need
you can fix this.
Okay, I will turn it back on if it stops. That's
okay.
peculiar. It shouldn't. It should have stuff. I mean, it could recorded all the day yesterday, so it should be fine today too.
Right,
Nicholas.
I'll keep a watch on it.
You have to
Nicholas,
re-invite it, yeah.
You do a great job organizing this conference. I just want to do a call out to you. You know, you get everything. You know, it's really organized. You know, and you keep everybody on schedule too. So nice work.
Can you all see my first slide here?
Yes.
Good. So what I'm going to talk about in this presentation is the very strong similarities with future moon bases and sustainable cities more advanced on Earth that also incorporate features of a circular economy. And speaking about lava tubes, we have one here. And as you can see here, funny thing that on the moon, you can actually fly using just your own muscles. But as always, all the inhabitants will need energy, food, water, air, and also access to greenery. And that's the focus of my presentation. If we start in space and looking on the resource flows on the ISS, you can see the picture here that air and waste and water circulates. And you don't need so much imagination to compare this to a more advanced city part of, in this case, a city part in Stockholm, where everything also is more or less recirculated. Organic waste produce biogas used for heating. Heating produce waste heat, which is also utilized. And wastewater is cleaned and reused for other purposes. So that's one type of similarities between moon bases and sustainable cities on this planet. So why do we actually need new technology and smart systems thinking?
Quick interruption. There's a thing in the chat about recording stopping. Has that been restarted?
That's a question for Niklas, I think.
Yes.
Niklas, did you get that?
I heard it, but my screen says recording. So I guess you are also recording for your side.
I'm
Okay.
not. I just saw a thing in the chat from
Nicholas, I think what it means is that your AI is not recording anymore. You'll need to re-invite your AI.
Okay.
Zoom is still recording the session, but the AI isn't.
Okay, so I can continue then.
Please continue, yes. And I actually think my AI...
So,
sorry.
On the moon and also on Earth, we need to increase the access to the physical resources we need for basic human welfare. Energy, water, metals, and Sean are the chemical elements, carbon, hydrogen, oxygen, and nitrogen, that all biological lives use, and that is necessary for food production. But we don't not only need to have more resources, we need to use the resources we have more efficiently. And that means a more advanced recycling. And that, in a way, that's more or less the same as a circular economy. So the conclusion is that we need to design tech system for abundant resources and for efficient circular resource flows. When you talk about circular economy, at least in Europe, you are talking about recycling shoes and textiles and building materials. But the vast flows that we actually use are, if we exclude mining stuff, is water and organic waste and waste heat. And we need to have this sort of recycling. We need to connect systems to each other and use both technical and biological solutions. And this is not just new technology. We have to have, let's say, a smart system thinking, connecting systems to each other, utilizing all resources in all waste streams. For instance, talking about wastewater, we reuse in this country the heat on wastewater, but very seldom the organics that are present in wastewater, and almost never the water itself, which is also a basic resource. And we can combine technology solutions and biological solutions to have a better recycling and resource efficiency, like a lot of speakers already have talked about. So let's talk about technology that actually comes or originates in space that could be very good for use on Earth. One example is the Swedish company Orbital Systems that has developed a very efficient shower. And that might seem like a small example, but in practice, we are using lots and lots of drinking water to clean ourselves. In this case, the nanoceram that is used on the ISS, together with UV light, recycle the water from the feet of this lady here, and it's recycled and cleaned before it's used again. And basically, this saves 90% of the water, but it also saves energy because when you have a shower, at least in cold countries like Sweden, it needs to be heated. But when you reuse shower water that is already heated, you save lots and lots of energy. Another Swedish example is SARI-R, which is not actually, this is a spin-off from space, working with indoor ventilation. But they named their company SARI-R to honor the female astronaut. And they have the systems used on ISS to get very much better ventilation systems by having lots and lots of sensors that check how much ventilation you actually need. And one side effect, this makes it possible to use the carbon dioxide that we all exhale in, let's say, a greenhouse or a vertical farm close to the building. Another example, this time from the US, is the NASA Killer Power System, a very small fission technology producing just heat and also with the Stirling engine for producing electricity. And now let's say the holy grail of energy production, space-based solar power. And this is also what ESA, the European Space Agency, is thinking about. And I'm sure most of you know the basic concept of this, to catch the sun's energy via solar cells and direct rays of microwaves or laser waves towards Earth. And then you have permanent energy, avoiding the problem with Earth-based solar power, which is, let's say, weather dependent. So let's go back. I stop here, and I have three takeaways from this presentation. The first takeaway is that the space community, if we consider ourselves to be part of a community, is that we must be much better to express to the general public and the politicians all the basic spin-offs that comes from space technology that could be applied to have a better environment on Earth, because that will motivate, let's say, long-term human settlement of the moon and elsewhere. But we also not only have, let's say, present technologies. The conditions on the moon are actually an innovation driver that I'm quite sure will generate much new good solutions. For instance, we have talked about dust. That problem will be recycled. I'm not sure that we could take away all dust close to our habitats or cities. Dust will be a problem for a long time on the moon. And smart systems of taking away small dust particles in the indoor air is useful everywhere, not only on the moon, but in most cases also on Earth and all workplaces. Other challenges on the moon is that the extreme temperatures during the lunar day and night. Of course, that will generate new thermal management technologies and new solutions like the SMR also small, medium nuclear reactors, or new solar technologies. But speaking about habitats in lava tunnels and other places underground, I'm sure that we have moon cities on different positions, but lava tunnels is a resource that will be used. And lots of cities on Earth are thinking of using the underground as a space, so to speak, to construct not only infrastructure, but also buildings. The inverse of a skyscraper, but going down instead of up. And indoor air quality, like quality of organic compounds and stuff like that, is critical for moon habitats, as Ben pointed out. If we solve this for the moon, we solve it also on Earth. But we also have lots of interesting solutions that are developed on Earth that could be useful on the moon. For instance, aquaponics, where you combine fish cultivating with greenhouse cultivation. That recycling system where fish poo and other stuff is recirculated, stayed on, let's say, some inert material, not in soil, but like in pebbles or stuff like that. Bacteria breaks down all the organic stuff, and that becomes nutrients for fish. Actually, in Sweden, we have started to do this, as you see on the picture here, that are growing bananas in very close to the city of Stockholm. And bananas is not a natural crop in this country. a bit too cold for that. Another thing that we'll also touch on speaking about free-done yuck factor. Singapore actually has a very advanced wastewater treatment system where they use microfiltration and reverse osmosis and radiation, UV radiation, to make the quality of wastewater so good that it actually is drinkable again. And in order to counteract the yuck factor, they use small plastic bottles and give it away for free to tourists and also inhabitants in Singapore. Another Singapore thing is the new Changi Airport in Singapore have lots and lots of vegetation inside and also small waterfall. And I'm quite convinced that on the cities, the future cities on the moon, we need more vegetation inside to be connected to nature. Some steward said, dogs and family friendly. This is a kind of dog friendly, at least. Another interesting technology that are developed on Earth that could be very useful on the moon, that is atmospheric water harvesting, where you have a desiccant that, the small white stuff that comes with when you buy electronics, not keeping things dry. But it's possible to use stuff like this to absorb water from the atmosphere and then by heating, retrieve the water. And there is a possibility that the indoor environment on Mon cities will be very humid. And that's not a very good thing because we thrive on let's say 20 to 30, maybe 40% humidity in the air. And I also could retrieve water from greenhouses and stuff like that. All things that could be very useful to have on the moon. So that's my second takeaway, that lots of things are developed on Earth, more or less connected to green tech that could be useful on the moon. And therefore, the conclusion is we should have more cooperation between those who develop space technology, especially when related to in situ resource utilization and life support, and those on Earth that work with green technologies. And what should we do then? We should actually communicate the similarity of both the challenges and opportunities for an abundant circular economy on Earth and on the moon. We must make some sort of information resources on technology and systems that we have on Earth that could be useful on the moon, and also vice versa, using, for instance, Lunarpedia or any other platform. And of course, we should test all these things in the analog moon habitats that Niklas and others are developing as demo sites and test beds for local food production, indoor greening, and the recycling of all the resources we need to have human welfare. What could cities on Earth learn from the space sector and what those cities on the moon we are planning? We need to have robust, reliable, low weight and low maintenance technical infrastructure in space, because in the short run, the astronauts have other things to do than taking care of the wastewater systems or the other kinds of infrastructure. Advanced solutions for ventilation and wastewater recycling, and temperature control, also is more essential also on Earth. We already talked about how plants could improve indoor air quality. This needs to be developed further. Also, experiments with high yield production of food crops and lots of other things. If we change the perspective and what could space cities on the moon and elsewhere learn from the more advanced cities on Earth, learning to connect systems to each other, learn from all new trends that are happening in urban agriculture and food production, learn how we are trying to use organisms from nature, plants, fungi, bacteria, etc., that actually is a part of infrastructure and purification of wastewater and recycling and stuff like that. And also learn to actually design and build an ecosystem. For instance, how do you make an indoor forest or an indoor park starting from zero? And the basic reason why I'm emphasizing the connection between these two trends is that people working with life support and resource utilization for moon and space, I would guess there are about 20,000 persons worldwide that work with some sort of aspect of this. But those working with green tech technology for urban sustainability and circular economy, at least there are 2 million persons, a factor of 100 more. So my third and last takeaway that these two groups should learn more from each other. So, thank you.
That was very, very good. I especially like that last slide showing the. Can you go back just one? Go back one slide, please.
This?
Yeah, good. Stop right there. Right. So we're sort of like saying it's 2 million backup people on Earth to support 20,000 people on Lunar people on the front lines.
Yeah.
Yeah,
That's
good.
a good
Okay, no,
perspective.
that's interesting. No, that's good. I mean, that's all jobs that we would need. Creativity. You know, we'd be doing it on Earth, but for Lunar. And for Lunar, we have 20,000 people. No. And now go back. I want to see a picture like it was one of your little parks or your forests. It could have been one of the early pictures.
What do you mean this one?
Well, wait a minute, stop. Quick. Okay, don't just stop right there. Okay, good. No, that's good right there. What would we call that? Is that a park? Is that what's the word for that?
Well, in practice, it's an airport. This is a part of the Changi Airport in Singapore.
This
so
actually exists.
Yes.
Okay, so wait, we should on the moon, we could have some number of those that would look like that. And I'm curious, like how many of those could fit in a pod?
Well, I
something
don't.
to work out. It might be difficult to work out on the spot, but I mean, that would be a good unit of measurement also.
That's a good question.
Yeah, no, good. Beautiful presentation. Very, very good. Very
Thank
nice.
you.
Any other questions
Or comments?
or comments, indeed?
Or disagreements?
So, yeah, I wanted to mention arcology here too, because the arcology people have a lot of the same motivations.
Yes.
So yeah, that's another group to tie in.
Yeah, definitely.
I'm also part of a group we call Arcology Circle, which is getting started, but one of its objectives is to build synergies between the different groups of people. So very similar to what you said.
Yes.
Yeah.
Good people think alike.
Well, it's a convergence
but-
of there's a convergence of humanity, and this is how we have ideas, and we develop to new levels of ideas.
Yes.
And one of my interests is in getting people to work closely together. It is actually, I mean, there are a lot of barriers to getting different groups to work together, getting different people to work together. And so it's not just a matter of informing people that these other groups exist. You actually, there's a lot more to it to get a good synergy going between those groups.
Yes, right. You're very right. It's not enough just pure information. You have to set up some sort of social circumstances that actually make some kind of benefits.
I'll be back in like 2 or 3 minutes, everybody.
Frida?
Yeah, well, it's interesting that you show the example from Singapore. I have seen that facility and it's beautiful. I think that one of the reasons that information and abilities will transfer from the moon to Earth is that, for example, on sewage treatment, there's tradition. We've always done it this way. We've always thrown our waste into the water. There's a whole great big field of civil engineering of they know how to handle all kinds of problems. We don't want to make any changes. The cost relationship is going to be very different if you're considering, well, gee, we've got to transport nitrogen and phosphorus. We got to put all this fertilizer. The expense of sending it up to the moon is going to be very expensive as compared to recycling. So
Yes,
I think
right.
that the development of these moon systems are going to transfer a lot of good stuff to the Earth and improve our situation on Earth.
Good. Here.
Yes.
Nicely stated, Frida.
Good point.
Yeah, very good point.
Frank?
I suspect that in a lot of ways it'll be similar to urban development in America versus Europe, because there's been a lot of pre-planning for a lot of the city centers and all that. It'll just be like a deeper layer of integration where you consider all of the biological factors that were not even like known, like about chemistry and physics back in the days when we settled the continent.
Mm-hmm.
Right. When you say the continent, you're referring to which continent here on Earth?
Oh, I mean, the Americas, and like,
okay.
I think of the moon as like, thing is, my background is like French Canadian, and I figured like if we can't do independence on Earth, well, might as well separate it. Independence
No,
from
I
might as
agree
well
completely.
separate from Earth altogether.
No. we're on the verge of a tremendous lunar expansion. If we'd only get it going, we just need the push and the funding. But no, these are fantastic ideas here.
Oh, totally. And the greatest aspect of it all is that like a lot of them like follow like a cost limitation factor, especially I mean across all domains. So I wouldn't be surprised if like at the end of the day, like the solutions for all this will be incredibly cheap aside from the research and development costs.
Yeah, once you start doing it, all of a sudden you realize, oh, we can do it this way, we can do it that way. What seemed like so difficult before you did it becomes then reasonable and doable once you start doing it.
The biofield doesn't demand a salary.
And a quick comment by Frida.
Well, you've got to realize the national reputations. I mean, the United States and Russia and Japan are spending enormous amounts of money to show how technologically advanced we are. And that's going to be a driving force for some of these things.
Right, good.
Boosting rights, yes.
Well, I'd still like to come up for a name for what we're looking at before we move on. Oh, that's a good slide, incidentally, right there, too. But that's a very good slide. But back up one slide.
So I'm sorry, I just missed the changes. This was not my intention. Do we have to stop, Niklas, or?
Yes, we do.
Okay,
Just
good.
kicked
Very
up
good.
to 5:30 now. So yes,
Very good.
thank you all. Thank you
very
for
good.
the presentation.